This will start our third lecture on section 1.4. This is the continuation of the example number 6, or exercise number 6 from page 42. So what we're going to be doing here is we're going to be drawing the linear model, the second linear model of approximation. So I'm going to go to my line tool as I had before, and this time what I'm going to do is I'm going to actually try to hit my y-intercept exactly, and then hit a couple more, or at least one more. And the 41 was the one that I actually hit exactly, as well as the y-intercept. Now I didn't do as good a job this time, so let me see if I can drag this thing up just a little bit. It looks like I can't, so I'm just going to undo that a couple of times and get rid of it. And one more time should do it. Okay. So there we go, and so I'm going to go up here and I'm going to go down there, and there we go. So this is fairly close to what I did before. Let me try one more time. Let's see, there we go. Maybe that's it. That one's better. Okay, so you see that there's a lot of different ways you can do this. I could hit that point and almost that point and do that point, and that would be different sets of errors. But the error that I did end up with for my model, and neither of these are showing them. I'm getting a little bit, it's a little bit frustrated. Let me go over here and let me do the line tool, and I can show you with that line tool what exactly I did hit. So that is the actual line. So you see this line that I've made with the line tool before, and it hits this one exactly and it hits this one exactly, which is the model that you see here and here. And this model gives me an error, a sum of about 6 for my different errors. A couple of negative ones, a couple of positive ones. The positive ones obviously end up being just slightly different or slightly bigger than my negative ones. And so the error is a lot smaller on this model, and that's what you're after. Now, by hand, there's not much we can really do about this. We can't make it perfect, and that's what regression is about. And I mentioned that in the notes and the lecture in the first section of this. So our idea is to get as good as we possibly can and as close as we humanly can without making the errors too big. So over here, let's continue with the questions quickly. It says, draw a line that comes close to the points in your scattergram. So we did that. And what is the t-intercept of the model? What does it mean in this situation? So let's go and look at the t-intercept. My t-intercept, not my r-intercept, my t-intercept down here. So it's about halfway between 50 and 55. So it's about 52 and a half. So what does that mean? Well, 52 and a half, this value right here at 52 and a half for t years, so 52 and a half years after the 1960, we'd expect for the deaths as a result of heart disease to be 0. Well, we know that's not really probable. Some people are going to continue to die from heart disease no matter what we do, and therefore we're going to have to assume that what we see here is model breakdown, and that's not really the accurate representation. So we're going to predict the death, the heart disease from for 2014. Well, 2014 is going to be even further down here, which means that we're going to be in negative values for death rates. That doesn't work either. That means that our model is not predicting as accurately as what we would like to see, and we're extrapolating the data and therefore seeing model breakdown. So these are the things that are actually an issue. And the problem is that we only have, based upon the population of the United States here, and as the population increases, these numbers are slightly different ratios, and also medical technology improves, so we expect the death rates to hopefully drop, but at some point there's not any more we can do for the majority of people. So this is all I really would like to say about this entire section. I think with section 1.3 combined with this section, you kind of get an idea of what's going on, and I'd like to focus more of our attention on the 1.3 material for this particular time. So that ends 1.3.